Hello everyone, Spicy here. I am here to show you guys how to use GTNH AE2 P2P. I specified GTNH because it's important to note that GTNH has fixed a lot of issues with how P2P works on server restart and just AE2 efficiency. So a lot of these principles will apply to AE2 P2P and other packs, but might cause issues on server restarts if you're playing something other than GTNH. So AE2 P2P is really good as an alternative to just running a main power line. The main reason being that if I'm running an LUV power line here and I decide to tier up, I can't just suddenly start pulling UV, UHV, whatever higher tier power out of this line. I have to rip the whole thing out in a lot of cases and replace it, and then I'm good to go. With with P2P power, you don't need to worry about that because you can just take the new power and plug it right into your system. Here you can see I have UV and UHV power on one line. So just looking at it as just the UV power, how this works is you're just going to take the P2P and you're going to right click on it and you are going to name it whatever you'd like just so you know what the input is. And you're just going to take a cable and connect it to whatever your battery buffer is, probably your LSC at this point, and you're good to go. There's your input. Then you just connect that to a cable. Now you can connect this to your mainnet, but I like to connect it to a subnet here. If you see this red cable, I will do all my power cables as red. The reason I keep it on a second subnet is you're going to be building all sorts of AE2 stuff off your mainnet. You're going to be building subnets, and if you accidentally connect a subnet that's connected to a controller to your mainnet, you're going to put the net in bridge mode, or you're going to bridge the network. And that is going to shut off the network. It's not going to work. That's not a big deal if it happens to your items and you can't transfer items for half a second. But where it is a big deal is if you're working off your power net and you power fail, and now all of a sudden, because your network's bridged, it can't transfer any of your power, and all of a sudden half your base just power failed. So I like to keep them on separate networks and just know that if I see these red cables here, nothing but red cable can attach to this because I don't want to even risk the chance. So you still have to be careful if you connect these two networks, of course. You've bridged them and you'll power fail stuff. But it's pretty easy to just be careful not to use Fluix cables around red cables, and you should never run into this issue. Now, as far as how the P2P actually works, what you're going to do is just grab a non-dense cable off the network, take a P2P tunnel GTEU. You can just craft these with one redstone ally cable and P2P in a circuit assembler. Super cheap and super easy to just have them in your inventory as the GTEU. You don't have to convert them using a memory card or right-clicking them with a cable or anything like that. So all you're going to do here is go to your cable you want to connect, and you want to check first your memory card. If you've never used a memory card in GTNH before, the advanced memory card, you're going to be by default on this bind to output mode. So this bind to output mode, where the arrow's pointing at the orange arrow, is not where you want to be because you have a chance in this mode to unbind your energy source. If you're unbinding your energy source, it's going to disconnect all of the possibly dozens of P2P power connections you have on that source, and you're going to have to reconnect them. It'll power fail everything there and cause problems. So what I like to do is keep it on this bind the input, red arrow pointing at the blue arrow. This means that worst case scenario is you'll accidentally bind to the wrong or to another output, and you'll disconnect that output from the input source and you'll have to rebind it, but that's one machine in most cases as opposed to unbinding your entire power of a certain voltage. So I like to keep it on this blue mode, and what you want to think is blue to blue. So you're going to bind to blue here, B to B. We're going to go to our UV64 amp, click bind, and now those are connected. So it's important to note here that this end of this cable is effectively the end of this cable. So if I'm running power through this and I try and pull power with an LUV wire, it's going to burn. Or if I try and volt an LUV machine, that LUV machine is going to explode. So you still have to follow GregTech power rules. So just place a cable that can handle the amount of power you're using on there and you'll be okay. Now you can place cables directly on to your P2P interfaces like this, your P2P tunnels, but there is power loss with the P2P. You lose 5% power, which is significantly more than you'll lose with any other cable in most cases, unless you're running them extremely long distances. So it is more expensive in power to use this, and that can cause some interesting interactions, especially as you get to higher amperages if you don't buffer the cables with something like a battery buffer. You can also directly output into an energy hatch. Again, just find your channel, make sure you're in bind to input, bind to blue. And this is just fine. You're not going to overamp the energy hatch. That's just not how they connect the cables. So this is totally safe. But again, that 5% loss can run into some issues because this will only accept 2 amps. It's only going to call for 2 amps, and those 2 amps of power are going to be cut by 5%. And that's going to leave you with less power than you're calling for. In most cases, it won't be an issue, but if you're really pushing the edge of that voltage, sometimes it can cause issues. An easy way around this is to use one of these options here. We have wire, we have a transformer, we have a battery buffer, which is definitely the best option, but it's also kind of expensive and bulky. Battery buffers can accept twice as many amps as they put out, so you're never going to run into issues with that 5% power loss on a battery buffer. The much cheaper and much more usable way is this diode, in my opinion. So diodes here are really cheap. The most expensive thing about them is really a machine haul or wire. And by this point in the game, that shouldn't be an issue for you. So what you're going to do is you're just going to wrench the diode to whatever wire output you want it to be at and connect any of the other sides to your P2P channel. And now this will buffer to 16 amps, but because of how the buffer works, it will just have a little bit of an energy buffer so that if for whatever reason for a second or two you get that call for a little more power than that power loss allows for, you won't power fail. Now this won't work for extended periods of time. If you try and run 16 amps off a 16 amp buffer and you use the full 16 amps for an extended period of time, like say a quad EBF setup, this could power fail. So that's when you'd want to use either a battery buffer or just add another P2P and connect two 16 amp diodes. So you just have to oversupply your power in most cases. And then you can just run off this diode or your transformer or your battery buffer into normal cables and run those into your machines. This means you don't have to do a P2P tunnel at every single machine. You can pull a 16 amp diode and connect, 15 centrifuges to it at that power tier. And you only needed one of these, and you just run the cable the rest of the way. You can also, or I guess the main reason you want to do P2P power is because you can transfer different amounts of power. So right here we have a UHV single block. If I tried to power this with UV, I'd have an issue. If I was running a normal cable line, as I explained earlier, you might have to pull out your whole cable line or at least run a whole new cable line to be able to power this machine. Instead, all you have to do with it P2P power is go to your power source, add a dynamo hatch, connect one wire cutter that wire into the P2P tunnel, give it a quick name, and come over here, find the one you want, bind to blue, make sure you're on bind to input, and this is good to go. We just upgraded a power tier. If we upgrade it again, all you have to do is break the machine, place down your upgraded machine or your upgraded energy hatch, and bind to your next tier once you add it over on the LSC. Now this right here is an example of one of those situations where you have a risk of power failing because of the 5% energy loss. In this case, if we're using all 16 amps of UV energy, you're using a very high level or like highly overclocked, say vacuum freezer recipe where it actually goes a little bit above the default voltage cost for that tier. This will be calling for 16 amps, but because of the 5% power loss, it's going to get something in the realm of 15.25. And while that wouldn't be an issue if you're calling under normal circumstances because of how overclocking and batch mode and various interactions with the multi-amp energy hatches works, sometimes you'll pass that buffer and power fail things. So generally, I like to say if I'm using a 16 amp diode, I use 15 amps of power. If I need more than 15 amps of power, I add another diode. It's as simple as that. So that is basically how P2P power works. There's some little intricacies with that 5% power loss, but compared to the annoyance and logistical issues of having to rerun new cables across your base every time you change power, it's far more versatile and adaptable, and is definitely worth that small loss, assuming you can afford it. So I would highly recommend you at least give this a try. Even if you don't use it for everything, I'm sure there's certainly situations where this would be particularly useful, even if you're running a main cable line and that's what you prefer to do. So it's definitely an important tool to learn to use as you make it through the mid-game of GTNH. Thanks for watching, and I hope you enjoyed the video.